Hello Level 2s and welcome back to 2.4 Atomic Structure and Bonding. This is Lesson 3 on shapes, and the final part B, won't take us long. I'm just going to show you a template answer. So this is pretty much what's required to get full marks for NCEA. Okay, now unfortunately, even though I hate saying it, there's a very easy way to get E for this paper and for these questions, and that's to parrot a template answer. And so I'm going to show you that template answer to give you the best shot of getting excellence for these questions. So here's an example of NH3 where you can see I've done the Lewis structure here. This is not being drawn as a 3D shape. We've still got to get to that. But there is one, two, three, 4 electron density regions. So this is derived from that tetrahedral shape. We know that there's a lone pair and we don't include the lone pairs, so we're going to take this top one off. Okay, however, that lone pair has contributed to the shape of this by repelling those bonded ones as well. So this is the template answer you're going to use, and you're going to practice it a few times today. So NH3 has 4 electron density regions, as we've just seen, around the central N atom. Okay, these electron density regions repel each other as far as possible, creating a parent geometry of tetrahedral. Okay, there are 3 bonding, 1, 2, 3, and 1 non-bonding pair of electrons, and that means the shape is trigonal pyramid. Okay, and it has a bond angle of 109, which comes from that parent geometry of tetrahedral. I hope that makes sense. You have to practice it a fair few times to get into the swing of this, and then it becomes second nature. I'm trying to teach you best practice to get top marks from the very beginning. Okay. So here's a task. I've asked you to draw the Lewis structure and the shape and then explain the shapes. This is a fairly big, sizable task, so feel free to pause and have a go. In the meantime, I'm just going to talk you through it. So if you want to just listen to me rabbit on, that's totally fine. So let's draw the Lewis structure. So valence electrons, carbons in group 14, so there are 4. Hydrogens in group 1, so there are 1 times 3, and chlorine is in group 17, so 7 valence electrons. So if you add all that up, that's 24 valence electrons. We now have to work out which atom's going to be in the middle, and that's going to be carbon, because it is the most electron deficient. You'll notice that carbon and chlorine are by themselves, so it had to be one of those two. Chlorine needs 1 electron, whereas though carbon needs 4. The rule I always teach is to put 8 electrons around the central atom first of all. 5, 6, 7, 8. Put your other atoms, so H, 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 chlorine, so 8. Oh, sorry, I've added this up wrong. How can that be 24? Whoops, the daisies. I was just doing the maths there, like that doesn't work. So we've got 3 and 7, 3 and 4 make 7, 14 electrons. There we go. So 8, 9, 10, 11, 12, 13, 14. So we don't need to make any multiple bonds. Okay, so we've got 1, 2, 3, 4 electron density regions. Now, I haven't taught you this. So this is the first time you're going to see this. But to draw tetrahedral and trigonal pyramid are only 2 3-dimensional shapes. The rest are planar and so nice and easy. So we have to draw 3D in a specific way. I'm going to teach you the way to teach my classes. So straight, and that bond angle kind of looks 120, but obviously it's supposed to be 109.5. But if you make it look almost 120, you're right. So straight, and then solid, and then dotty. And you've not seen these, but what do these solid and dotty represent? And straight. So straight represents in the plane of the page. So if you have a look at your tetrahedral model, so if you just kind of bring yours in front of you, so 2 of them, if you hold them like that, are in the plane of the page together. Okay, so they fit plane of the page. Then there's one pointing towards you and one pointing towards me. Okay, and that's what I've done here, pointing towards me, pointing towards you. So that's what they stand for, and then you can put the atoms in H, Cl, H, and H. And during our lessons this week, I'm going to check that you can do those. So I always get my kids to chant straight, solid, dotty, straight, solid, dotty. And you'll see I'll show you some more stuff as we go on. Okay, so that's drawing of those. Let's do BF3. 3, group 13. 21 makes 24 electrons. Central atom will be boron. 1, 2, 3, 4, 5, 6. I'm only going to do 6 here, remembering boron's the exception. Fluorine, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Happy days. This is 3 electron density regions, so therefore it's trigonal planar. Okay. And all of the bonds are in the plane of the page. So just like so. SO2, 6 times 2. So this gives us 18 electrons. Sulfur in the middle because it's by itself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And 17, 18. So one of them doesn't have enough electrons, so we're going to have to move this pair and create a multiple bond. So I'm going to cross those off, and therefore we've got 1, 2, 3 electron density regions, with 2 being bonded and 1 being non-bonded. So therefore it's going to be S, okay, O, O, and that shape is bent, and it's planar as well, so you don't have to worry about 3D. So there's only one that you had to worry about being 3D, and that was the first one. I've realised how ugly this looks, so I'll draw prettier ones as we go through. So let's now verbally discuss the shape. Now you don't have the template in front of you, but I know it off by heart, so I'm going to go through it with you. Okay, CH3Cl has got 4 electron density regions around the central C atom. These repel as far as possible, creating a parent geometry of tetrahedral. There are 4 bonding and 0 non-bonding pairs of electrons, so the shape is also tetrahedral. Hopefully that makes sense. I've typed it all out. BF3 has got 3 electron density regions around the central B atom. These repel as far as possible, creating a parent geometry of trigonal planar. There are 3 bonding and 0 non-bonding, so therefore the shape is also trigonal planar with a bond angle of 120. SO2 has 3 electron density regions that repel around the central S atom, that repel as far as possible, creating a parent geometry of trigonal planar. Okay, there are 2 bonding and 1 non-bonding, so therefore the shape is bent with a bond angle of 120 degrees. Hopefully that makes sense. I've typed these all out for you so you can go through and let me know if you've got any questions. Okay, so this was what I was showing you before, that straight, solid dotty, drawn a lot nicer. So straight in the plane of the page, solid coming out towards me, dotty going towards you, and that's how we draw them. And it just takes practice. So I'm going to get you guys to draw me some and put them on your OneNote, and I'll critique them. A wee hint, I try and make this look 120-ish. I know that it's 109.5, but if you kind of make it look 120-ish, then if you kind of do a right angle here, where kids go wrong is it's not physically possible for this bond to be at a 90-degree angle. So if you make sure that these 2 bonds are within that 90-degree plane, you'll be on the right page, the 90-degree angle, sorry. Okay, so try and make those 2 bonds smush together in that 90-degree bit, and then you'll have drawn it correctly. Okay, so all of them are 2D, so linear, 2D, which means planar. Okay, trigonal planar, bent planar, bent planar, so planar, planar. So 4 out of 6 of your shapes are planar, which is nice and easy, which just means you just use the straights. Okay, but your trigonal pyramid, okay, just take off that top one and keep the rest the same, and tetrahedral, straight, solid dotty. I hate the way this is drawn. It's not actually correct. That bond needs to be further down. You'll see that. So many examples on the internet. So try and smush these so they're within that 90-degree plane. Okay, so smush it down. You'll see incorrectly drawn ones all over the place, which makes it hard for you guys, okay? So smush those down. All right, team. That is us done. There is a shapes worksheet on your OneNote that I'd like you to do. I'll quickly finish off with this last one of drawing CH4 as 3D. Okay. And NH3. So here's CH4. So we're going to do straight at 120, solid and dotty, keeping those in the 90-degree plane. Let's do NH3. Okay, this time you don't do that top one. So it's just going to be N. That straight's going to be there still, solid, and then dotty. Keeping that within that 90-degree plane. I hope that makes sense, folks. Please now do your shapes worksheet and we'll be on Teams shortly. Okay, team. Bye.